Hello students, today's class we start the new exercise 6.4 of chapter 6 Triangles and its properties. Today we learn the new property of triangle about sides, that is length of sides. The property is that sum of the length of any two sides of triangle is greater than the third side. I'll explain with one example. Look at this triangle. B is the position of your home and C is position of your school. Which route is longer? You can have two routes. You can go from B to A and then A to C. Or else directly you can go from B to C. In that, which route is longer? Yes, B to A plus A to C route is longer than B to C. This example shows that this property, that is sum of length of any two sides of triangle is greater than the third side, isn't it? AB is one side, AC is another side. If we add the two sides measures, you will get the new measure. That measure is greater than the third side BC. Okay, all the measures are not make a triangle. Okay, it has to, the length of measures has to satisfy this property. For example, add any two sides, that is 3 plus 2 is equal to 5. That 5 should be greater than 6, but here 5 is less than 6. So triangle is not possible for these measures. Understand? For example, draw 6 centimeter and 3 and 2 centimeter. If we draw two sides, means these two sides not meet. It is not a closed figure, so it is not possible these measures. Similarly, another one example we are having two measures 4 centimeter and 4 centimeter. Third measure is 8 centimeter. If you add the two sides measures, you will get 8. That 8 is equal to third side measure 8. Got it? So it is also not possible. See, if you construct a triangle, it will not be closed figure. Got it? So a triangle possible. When it is possible, the sum of the length of any two sides of triangle is always greater than the third side. Got it? This is the new property. Using this property, we are going to solve problems of exercise 6.4. First one, is it possible to have a triangle with the following sides? Yeah, first one, we'll add first two sides measure 2 plus 3. What you are getting? 5. That 5 is equal to the remaining side measure. So it is not possible. And second one, for add two sides measure, that is 3 plus 6. That 3 plus 6 is greater than 7. Is it? 3 plus 6 is how much? 9. 9 is greater than 7. So it is possible. Yes. It satisfies that property. Similarly, we will check for third measures, that is 6 centimeter, 3 centimeter and 2 centimeter. While adding the measures, you should add the smaller sides measures. Then only you can compare with the greater side measure. See, look at this example. 3 plus 6. These two measures are smaller than 7 centimeters. So you should add these two. And then first example, greater measure is 5. So don't disturb this measure. You should add these two. 2 plus 3. And compare with the third side. Similarly, second one also. Okay, 6 centimeter is greater than these two. So you should add these two. Side, that is 3 plus 2, 5. Compare with 6. That way you can check the given measures are sides of triangle or not. Question 2. Take any point O in the interior of triangle PQR. Is OP plus OQ greater than PQ? Or OQ plus OR greater than QR? Or OR plus OP greater than RP? They are asking three part of questions from this triangle PQR. Now this first in this first part, OP, OQ and PQ, these three are not sides of triangle. That is, OP and OQ are not sides of the triangle PQR, but PQ is one side. Yes. Using the dotted lines, join OP, OR and OQ. Now you will get three triangles. That is, POQ is one triangle, POR one triangle, and ROQ another triangle. We should apply the property, that is, sum of any two sides of triangle is greater than the third side. We should check for all the three triangle. If this property is satisfied, we can write yes, otherwise no. First, we'll select the triangle POQ, in which is the longest side PQ. We should add PO and OQ. Got it? Yes. OP, that is OP plus OQ is greater than PQ. Yes. So OQ form a triangle. Similarly, check another one triangle. Next, we'll take RQO triangle, in which RQ is the lengthiest side. We should add remaining two sides of this triangle, RO and OQ. If we add these two measures, that sum is greater than this lengthiest side measure. Okay. Yes. Here also, this triangle also, that property is satisfied. That is, RO plus OQ is greater than QR. So RQO form a triangle. Next, we'll check with the third triangle POR. PR is longest side. We should add these two, OR plus OP. These, if you add these two, that sum is greater than the third side. Without measure, we can say. Okay. Let's copy down this solution. Further draw this figure. Question 3. AM is a median of triangle ABC. Is AB plus BC plus CA greater than 2AM? Consider the sides of triangle ABM and triangle AMC. Here they are given one triangle ABC, in which AM is a median. Okay, means M is the midpoint of BC. They are asking, is AB plus BC plus CA greater than 2AM? We should prove this. We should bring this answer and write yes or no. Okay. Yes, for that we should use that property. Which property? Sum of any two sides of triangle is always greater than the third side. For that we will use these two triangles. Okay. First, in triangle ABM. Triangle ABM. Okay. In which AM is longest side. So we will add these two remaining two sides measures. That is AB plus BM. Okay, sum of these two is greater than AM. Keep this is 1. Second triangle we are having AMC. I'll write clearly. Once delete all. First I am selecting this triangle. In triangle ABM, adding these two sides, AB plus BM. Measures we are not having, so we are adding the side's name. Okay, AB plus BM is greater than AM, because AM is third side. These two are sum of two sides and AM is third side. We are applying that property. It is 1. And apply the same property for this triangle AMC, because they are given in the hint Consider the sides of triangle ABM and AMC. Got it? Yes. In the second triangle AMC, I am adding AC and MC. AC plus MC is greater than the third side AM. For both the triangle, AM is the third side, common side, right? Yes, it is 2. Got it? I have used 2 triangles. Okay, triangle ABM applied property, in triangle AMC also applied property. I am going to add these 2 conditions. That is, we are having greater than sign. It is a inequality sign. Greater than or less than. These 2 are inequality sign. This is equal sign. That is equality sign. I am going to add these 2 conditions. First, greater than greater than sign left hand side I am adding. Okay, yeah, this page only I will explain. Left hand side we are having AB, BM, AC, MC. I am adding all. AB plus BM plus AC plus MC. Got it? What I did? The 2 conditions, 1 and 2 conditions, greater than side, left hand side terms are added here. AB plus BM plus AC plus MC. Similarly, greater than sign, right hand side also I am adding. So put here greater than. Right hand side, first condition AM, second condition also AM. So AM plus AM. Got it? AM plus AM. I will write clearly only this condition. That is last condition, that is AB plus BM plus AC plus MC is greater than AM plus AM. Got it? It is right hand sides. This is left hand sides of 2 conditions. Now AB and AC I am collecting first. AB plus AC and combined these 2. I am going to combine these 2. BM plus MC. Write in one bracket. Why? I will explain. Next step. AM plus AM, right hand side. If you add these 2, you will get 2 AM. Because these 2 are like terms, no? Same terms, AM and AM. So we can add 2 AM, we will get. Now, why I put these 2 terms in bracket, that is these 2 sides in bracket? Because it has common vertex M. Okay, BM plus MC. Look at the figure. Look at the figure. BM and MC. In the figure, if we add BM and MC, what we will get? We will get the whole side BC. Got it? BM is one part, MC is one part. If we join the 2 parts, we will get one side BC. Yes, that only I am going to write now. That is AB plus AC, write as it is. Okay, BM plus MC is what? If you add the 2 sides, we will get BC is greater than 2 AM. Right hand side, write as it is. This is what we have to prove. AB plus BC. BC we are having here. Okay. AB plus BC plus AC, that is CA is given. Okay. Same. Both are same. Is greater than 2 AM. Yes, it is true. We have to write conclusion in the last step. Understand? I'll show the solution now. Yes, this is the solution. Copy down. You can watch the video solution of these 3 problems. Okay, till now we end up the session because only we have solved 3 problems. Use the property sum of length of any two sides is always greater than the third side.
Question 1 says, is it possible to have a triangle with the following sides? And then we are given these 3 parts. In each part we are given 3 lengths, and we have to check whether it is possible to draw a triangle with these 3 lengths as the side lengths. Now to solve this question, we will use the property of triangles that the sum of any two sides of a triangle must be greater than the third side. So in each part, we will check the sum of every pair of lengths and determine whether it is greater than the third length. Okay, so let's start with the first part. In the first part, the sides are given as 2 centimeter, 3 centimeter and 5 centimeter. So first we check, is, let's say, the sum of the first two sides greater than the third side. So is 2 plus 3 greater than 5? And the answer to this is no. 2 plus 3 is equal to 5. So just by checking this first pair, we can say that in question 1, it is not possible to draw a triangle with these 3 sides. And so the answer for part 1 is no. Okay, so that is part 1. Now in part 2, the 3 sides are 3 centimeter, 6 centimeter and 7 centimeter. So we will check the sum of each pair of sides and see whether it is greater than the third side or not. So first we check, is 3 plus 6, the sum of the first two, greater than 7? And 3 plus 6 is 9 and 9 is greater than 7. So yes, the answer is yes to this check. Then we check, is 6 plus 7, the sum of the second and the third one, is this greater than the first side? Is 6 plus 7 greater than 3? And 6 plus 7 is 13. So the answer to this is also yes. And then we check, is the sum of the first and the third one, so is 3 plus 7 greater than the second one? So is 3 plus 7 greater than 6? And 3 plus 7 is 10. So and 10 is greater than 6. So the answer is yes to this as well. So for this set of sides, the sum of each pair is greater than the third side, and therefore it is possible to have a triangle with these 3 sides. So the answer is yes for part 2. So that's part 2, and now we come to part 3, in which the 3 sides are 6 centimeter, 3 centimeter and 2 centimeter. So once again we will check the sum of each pair and see if it is greater than the third part or not, the third side or not. So first we check, is 6 plus 3 greater than 2? The sum of the first two, is it greater than the third one? And 6 plus 3 is 9 and 9 is greater than 2. So the answer is yes to this. Then we check if the sum of the second and the third one, these two, is it greater than the first one? So is 3 plus 2 greater than 6? And 3 plus 2 is 5 and 5 is not greater than 6. So the answer is no to this case. So for this set of sides, the sum of 3 plus 2 is not greater than 6, and therefore it is not possible to have a triangle with these 3 sides. So the answer is no for part 3. And with this we have completed question number 1. In question 2 of this exercise, the problem statement says, take any point O in the interior of a triangle PQR. So if you observe this figure here, O has been taken as any point inside the triangle PQR. Then in the first part, we have to check, is OP plus OQ greater than PQ? So let's draw the segments OP and OQ. So OP is this segment and OQ is this segment here. So we have to check, is OP plus OQ, is this greater than PQ? Well, what do you think? The answer to this is actually quite simple. We can simply make use of the property that in a triangle, the sum of any two sides of a triangle is greater than its third side. So in triangle OPQ, the sum of the two sides OP and OQ will of course be greater than PQ. So the answer to this part will be yes. OP plus OQ will be greater than PQ. Similarly, in part 2, we have to check, is OQ plus OR greater than QR? So let's draw the segment OR as well, like this. And now we have to check, is OQ plus OR, so OQ is this segment, OR is this segment, is the sum of these two segments greater than QR? Well, once again, we can make use of this property that the sum of the two sides OQ and OR in triangle OQR will be greater than the third side QR. So the answer is yes to part 2 as well. And finally, in part 3, we have to do a similar check. We have to see if OR plus OP is greater than RP. So OR is this segment and OP is this segment here, and we have to check if the sum of these two segments is greater than RP. And once again, we can make use of this property. In the triangle ORP, the sum of the two sides OR and OP will be greater than RP. So the answer is yes to part 3 as well. So the answer is yes for all the 3 parts, and that completes question number 2. Question 3 of this exercise says AM is a median of a triangle ABC. So a median is a segment which joins a vertex to the midpoint of the opposite side. So AM is a median, which means that M is the midpoint of BC. And then the question asks us, is AB plus BC plus CA greater than 2AM? So on the left side we have AB plus BC plus CA, the sum of the 3 sides of the triangle. And on the right side we have 2 times AM, 2 times the length of the median AM. And we have to check whether the left side is greater than the right side or not. And then there's also a hint which says consider the sides of triangles ABM and AMC. So let's do that. Let's first consider the sides of triangle ABM. So triangle ABM, I'm going to highlight it for you. Triangle ABM is this triangle that I have highlighted. Now we can make use of the property that in any triangle the sum of any two sides is greater than the third side. So in triangle ABM that I've highlighted, we can say that the sum of AB plus BM will be greater than AM, right? So by using this property, we can say that in triangle ABM, we must have AB plus BM as greater than AM. Now let's consider the other triangle, triangle AMC, and again I'm going to highlight this triangle for you. So triangle AMC is this triangle, and again if we apply this property to triangle AMC, we must have in this triangle AC plus CM must be greater than AM. So in triangle AMC, we must have AC plus CM as greater than AM. So both of these inequalities that we have written, AB plus BM greater than AM and AC plus CM greater than AM, both of these inequalities follow from this property of triangles. So let's call this inequality 1 and let's call this inequality 2, and now all we have to do is we have to add these two inequalities. So if we add them, then on the left side we will get AB plus AC plus BM plus CM. But we note that BM plus CM is simply this segment plus this segment, BM plus CM. This is simply equal to BC. So on the left side we get AB plus BM plus CM. We can combine it and write it as BC, and then we get AC, which we can also write as CA. So on the left side I get AB plus BC plus CA greater than, on the right side I get AM plus AM, and that gives me 2AM. So this inequality that we have obtained, AB plus BC plus CA greater than 2AM, by adding 1 and 2, this is what we had to find. This is what we had to check. So the answer to this question is yes, the sum of the sides is greater than twice the median. And this completes question number 3.